Today's talk is understanding and deploying hosted private cloud concepts and implementation. And while you see 3 people up on the slide, 2 of them are here in spirit only. I'm Tom Schinder. I'm a principal writer and knowledge engineer in the Windows Server and Cloud Division Information Experience Group. I work on a sub-team called the Solutions Group, where we handle difficult-to-document solutions, and one of those difficult-to-document solutions is private cloud infrastructure. And so in this talk today, Yuri Diogenes, who's a senior technical writer in the Server and Cloud Division, and Josh Adams, who's a senior program manager in our Enterprise Engineering Center, actually helped put together this talk, so I want to give them props for what's delivered today. So if you like what you see, please give them credit. If you don't like what you see, then give me all that credit. The talk today is mostly demo with a little bit of conceptual stuff in between. Now, in the title I say hosted private cloud because what we're going to present today are some design considerations and then 3 design patterns that we have for a cloud infrastructure. And what I mean by a cloud infrastructure is the core compute, networking, and storage components. While it's presented here as hosted private cloud, where your private cloud is being hosted by a third party, the same concepts and implementation ideas and design patterns can also be used on your on-premises cloud as well. So let's get started. We're not going to have too many slides because most of this is going to be demos of us configuring one of the design patterns from end to end. So we'll start off with a few concepts and a quick overview of the private cloud reference architecture. I'm going to kind of speed through that. Was anybody at the principles, concepts, and patterns talk yesterday? And I talked about that. Okay. So I'm going to gloss over that pretty quick so you don't have to suffer through that again. But I want to give you a foundation for what we're looking at, give you a high-level view. And then after that, I'm going to cover some deployment scenarios that describe 3 primary design patterns. And I would like this to be an interactive session. In contrast to the principles talk where I went on my own because it was more of a lecture format, this one I would like to be as interactive as possible because these design patterns were put together by us. We had our engineers and our product group managers get together and think about what would be the best design patterns for creating the core infrastructure for a cloud environment. Now, what I would like to see is if you think we're crazy, if maybe we're on the right track, if we're in between, or maybe this actually will work for you. So if you have any questions about any of the components, please raise your hand. If I don't see you, then yell out because I really want to get that feedback. And then we'll go through a short design planning and implementing exercise where we'll look at a collection of design requirements and see which pattern might fit each of those designs, given some example design requirements. And then we'll have the demos. The demos will actually be interspersed throughout the talk. So we won't wait too long for the first demo because I figure if we do a demo early, I'll get you hooked and you'll want to see it from end to end and you won't leave. So hopefully the story is compelling from the beginning. So first, building the cloud infrastructure on Windows Server 2012. So we only will be talking about the Windows Server 2012 platform technologies. We won't be talking about System Center. And we did this consciously because while we would love for you to use System Center, and System Center is a very enabling technology for the cloud, it provides the automation, it provides the self-service, it provides all the things I talked about in the principles talk. Today I can talk about products because this is not an architectural session. So System Center can provide all those things, but if you're a hoster, you may already have your own fabric management system that you prefer, right? So we want to demonstrate what the core platform technologies are that you'll be able to leverage maybe with your own systems if you don't want to use part or all of System Center. First, I want to talk about our reference model in terms of private cloud. This is how we currently think about private cloud, where private cloud is a complex system. I think we can all admit to that. And while it shares many things with traditional data center, there are many components that go into making a private cloud what it is that is different than a traditional data center. So we have to look at the entire problem domain and break down the problem domains into security and management. And management helps us manage the infrastructure layer. The infrastructure layer helps us support the platform layer. The platform layer helps us run the software layer. And the software layer helps us implement on the service delivery layer. We'll go into more details on this if you choose to come to the security talk for private cloud, but I'm not going to delve into this. But the reason why I wanted to present you this reference architecture is to show that we're only focusing on one chunk here, and this is the infrastructure layer. Well, we'll be taking a look at the hypervisor, we'll be taking a look at the storage component, the compute component, and the networking component as we do the demos today. Pardon? A stamp has to do with the hardware architecture that you use. So you want to have, I talked about homogenization as part of an enabler for the private cloud. So our stamp would be the make and model of the servers, the make and model of the storage, and the make and model of the networking components. And those would represent a stamp for, say, a upgrade, not an upgrade domain, but a... Yes, exactly. So let's look at some of the scenarios. So when we're building our cloud infrastructure using the platform technologies, we can design the Hyper-V cluster to host VMs in an IIS cloud. We can perform operations such as onboarding new and moving existing virtual machines. Because remember, when we talk about cloud, we're talking about the decoupling of the services from the hardware infrastructure. So the machines are going to be very mobile throughout the cloud infrastructure, and of course, virtual machine maintenance. Then I'll talk about the three design patterns, which are non-converged enterprise, converged data center with file server storage, and converged data center without dedicated storage node. And I'll describe now what I mean by converged, and, after I make it clear that this is a cloud infrastructure and not a complete IaaS solution. Right now, if you try to find how to build a complete infrastructure as a service solution using our products, or actually anybody's products, any of our competitors, you'll find it very difficult to find documentation to do that. So at the end of August, we will be complete with our document set for building out the cloud infrastructure, the core compute, networking, and storage. And that will be available on TechNet. And then after that, we take on the big project, which is how to take that core infrastructure and then build infrastructure and a service on top of that. And that's going to be very challenging because it's complex. But my job and my team's job as knowledge engineers is to make it as easy as possible for you to instantiate infrastructure as a service so that you can then build services on top of that IaaS. Okay, so the first pattern I want to introduce is what we call the non-converged enterprise configuration. When I say non-converged, I'm speaking specifically about the networking configuration in terms of convergence, just the networking configuration. So you can see here, let's see, I didn't do that, so I'll have to point. So you can see here that we have separate NICs for the different traffic patterns. So we have separate NICs for the live migration, cluster, and management traffic. And then we have another separate NIC for what we call the tenant traffic. So if we group these three logically, I mean, these are physical NICs connected to separate physical networks. We have physical separation between the infrastructure traffic, the cloud infrastructure traffic, and what we call the tenant traffic, where all the VM traffic comes out of. This is consistent with the guidance we provided you with Windows Server 2008 R2. It was challenging because of the technology limitations we had at the time, because a lot of blade servers especially don't often give us the luxury of having this many ports. Or if we have this many ports, we're limited, like where's our out-of-band management port here? You know, we run into troubles with that. So what we can do here is an example. We use 1 gigabit NICs for this infrastructure traffic, and then we can use either teamed 1 gigabit NICs or 10 gig and take advantage of other technologies such as single root I/O virtualization, receive site scaling, receive site coalescing that's available with Windows Server 2012. We can take advantage of NIC teaming and several other hardware offloads that allow us to move the processing into the NIC and away from the main processor so that we can increase VM density on each machine. Now, the second design pattern that we've considered that might be of interest starts to take advantage of capabilities that are introduced in Windows Server 2012. So we move away from design patterns that were focused on previous versions of Windows, and we start to leverage new capabilities in Server 2012. So we call this the converged data center plus file server storage. And what you can see here is that we actually have two clusters. We have a file server cluster over here, and we have a Hyper-V cluster over here. The purpose of the file server cluster is actually to host the VHDX files, or if you prefer, the VMware files that you would access over NFS, because Server 2012 fully supports NFS if you want to use that for storage of your ESX infrastructure. Then we have a separate compute cluster where we have a single NIC, a single 10 gig NIC that hosts the infrastructure traffic. And then we have a second NIC, 10 gig NIC or 1 gig NIC. The reason why we say 1 or 10, we refer to this traffic to the tenants as north-south traffic versus the traffic on the infrastructure network that we refer to as east-west traffic. So depending on the traffic profiles that you see for your tenant workloads, may not be that bandwidth intensive, so you might not need the expense of a 10 gig NIC here. You would have to assess the type of workloads you expect to host in your private cloud infrastructure. It may be that you'll just want to do a network team. Windows Server 12 supports teaming out of the box, so you don't need to depend on Intel or Broadcom or any of the other vendors anymore for the teaming solution. You can actually team different vendors' NICs if you like using our inbox solution. So if you don't have high bandwidth requirements for your tenant traffic, you can get away with maybe teaming 1 gig NICs, but if you expect a lot of bandwidth per server, then you can throw in a 10 gigabit Ethernet there. Now the trick here to make this work is that our storage cluster can host any kind of storage medium. So you could use our Spaces capability where we just use a JBOD and a bunch of SAS disks. If you already have sunk costs and you have a fiber channel solution, you can hook the fiber channel up to the storage array. If you want to use iSCSI, you can use that too. We don't expect to be prescriptive about that because each IT org or each hoster will be interested in their own storage, and you'll probably want to provide tiered storage as part of your menu of options that you present to the consumers of your cloud, and then bill accordingly based on the tiering that you're providing them. But how do we make this work, though? So the compute is actually happening here on the compute cluster, but they're connecting to their virtual disk files over here, and in order to make that work, we have to take advantage of new capabilities in the SMB3 protocol. Okay, Server Message Block 3.0 introduces a ton of new capabilities that gives us almost 99%. Almost 99%, we're approaching 100% of what you would see with direct attached storage. As a matter of fact, I was talking to Jose Barreto, who's the key program manager for SMB 3.0, and he told me that over SMB 3.0, they were able to push almost 16 gigabits per second over the wire. Okay? And I asked him, why are we limited to 16 gigabits per second over the wire? And he said, well, because we're pushing the limits of the PCI 2.0 spec. We have to wait for PCI 3.0, which is actually very exciting when you think about it, because always in our history, the software was lagging the hardware. It's like, well, the hardware can do X amount of performance, but the software won't support it. Now it's amazing to think that the software is starting to push the limits of the hardware. We're pushing Intel and AMD. Give us more. We can do more with the software because we've learned so much over the last couple of decades. This also provides the option of scaling your compute and storage separately, which some people might find an interesting option. Then we have this one, which a couple of my colleagues said to me, are you sure you want to present this option to a bunch of people at TechEd? Because they may start laughing and pointing a crooked finger at you and saying that you're crazy. But I like to push the edge, and so let me present this option to you and see what you think. This is what we call the converged network and storage solution. So the storage is connected directly to the compute cluster. The Hyper-V cluster is the compute cluster. So you can use any storage you like. You can use our storage spaces with JBODs and SAS disks, or you can use the Fiber Channel or iSCSI, whatever you prefer to use. That's not controversial. Most of us connect our storage to our compute clusters anyhow, so that's old hat. What is not necessarily old hat is that we're going to run all traffic through the Hyper-V extensible switch. What that means is that this infrastructure traffic will be moving through the same switch as the tenant traffic, and they will all be connected to a teamed pair, or can be more than two. You can team up to 32 NICs in Server 2012. Through this team network interface that goes into the tenant and infrastructure network. I left out the infrastructure network here, but it should be tenants and infrastructure. Now, how can we do that? Because it's really critical that we isolate the infrastructure traffic from the tenant traffic. As I'll talk about in the private cloud security talk, never should a tenant ever have any capability, possibility, or any other ability that you can think of interfacing with the core infrastructure, because one rogue tenant can take down the entire cloud infrastructure, and that can have cataclysmic effects on service delivery and service availability. So we can't do that. So in Windows Server 2012, we can take advantage of new capabilities in a Hyper-V extensible switch, such as port ACLs, so that we can configure the switch so that tenants are not allowed to touch any of the addresses in the infrastructure network. Another concern is, how do we make sure that the tenants don't walk all over the infrastructure traffic, which is probably unlikely because their traffic profile is not near the amount of bandwidth we need for this traffic here, because we have to do live migrations and storage migrations with the infrastructure traffic, and that requires a remarkable amount of bandwidth. So we'll take advantage of new QoS policies, quality of service policies, that are now available with the Hyper-V extensible switch. In addition, even though I said I was going to talk about core platform technologies, we also have the option to use a third party and plug in something like a Cisco 1000V into there and get even more elegant traffic shaping abilities. Now, there's a lot more details in this, and if you want to learn more, you can go to these talks. I think actually the Architecting Private Clouds is being delivered now. This is the Orlando slide here. But you can check these recordings and dig deeper into that. I'm not going to go any more into the conceptual stuff regarding those three. So now, let's talk about some scenarios, and we'll start with storage, and then we'll configure the storage in our demo environment. So here are a list of possible requirements a customer might present to you who's interested in building a hosted cloud or a private cloud. That I need very low-cost storage. Most of my VMs are disk-bound. My infrastructure doesn't yet support 10 gig Ethernet. I need the highest performance possible. Everybody needs the highest performance possible. I need to scale storage and compute together, and I need a highly available solution. So with those requirements set in mind, what might we have for them? Well, what we can do is we can create a single cluster that looks like this. We can then have well-connected storage, and what I mean by well-connected storage is that each host in the cluster is directly connected to storage. And we could use either our new storage spaces capability or a traditional storage area network. Okay? So you can see here, if you were at the principals talk, you can see here that we've defined scale units of 2 hosts. So you would start with, if you were just beginning, for example, maybe a small company is just beginning, you're just testing the solution, you would start with a single scale unit, and then you could add another scale unit, watching historical trends, right, like I talked about yesterday, so that you know the growth in the use of the service, and then you'll know when you need a next scale unit, then you'll watch the growth there, and you'll learn when you need to add more capacity by adding more scale units so that you can provide that perception of infinite capacity. Very important private cloud that we create that perception of infinite capacity and the perception of continuous availability. Those two are tightly intertwined. Now, here's another set of requirements the customer may give you. They say, I need to manage my compute and storage infrastructure separately because there may be some cabling or other physical infrastructure constraints in place that leads to this requirement. I need the flexibility of file-based storage for VHDs using either SMB or if you use VMware NFS. My primary workloads are expected to be compute-bound, and we need to keep the storage team and the compute teams as separate as possible because of corporate culture. So what might that look like? Well, that might look like the non-converged with separate file server storage. So we would have the compute cluster that we see here on the left. We would have a storage cluster that we see here on the right. We take advantage of CSV, so all the nodes in the storage cluster can see the storage. We would use file-based storage, so the VHDs would be accessible to the compute cluster via a simple file share. It's insanely easy. So when you think about it, when we use the file-based storage, the guys on the compute cluster who are having to spin up the VMs, or your fabric management system is spinning up VMs per policy based on the self-service catalog menu, instead of having to deal with blends and configuring the storage that's directly attached to the compute cluster, bam, you just connect to a file share. I mean, no brain, no pain, right? I mean, it doesn't get easier than that. And of course, you can flexible block storage options. You know, as I said before, you can use SAN or JBOD and SAS. All right. Josh usually does this, but he taught me how to do it, so let's see how it goes here. So we're going to switch over to the demo environment, and we're going to configure the storage any day now. Aha. Looks good? All right, so the first thing we need to do is I want to give you a little lay of the land here. So over here on the left, you can see 4 computers. They're HC2N1, HC2N2, HC2N5, HC2N6. N1 and N2 will be a 2-node compute cluster that we will create. And then 5 and 6 will be a 2-node storage cluster that we're going to create. And we're going to start with the storage cluster. So the first thing we're going to do is create the storage cluster on this machine. And so we will start Server Manager. Oh, wait a minute, wrong machine here. Doop. Start a Server Manager on the hosts. We want to go here. Okay. Scroll to the right. 3 social credits. Thank you. All right. So let's go to our server manager. And in server manager, we will open up the failover cluster manager console. So the first thing you would do when you're setting up a cluster is you would run the cluster validation. Now, cluster validation takes a bit of time, so I actually ran it in advance so that we wouldn't have to wait. The cluster validation tool does very comprehensive checks of all the machines that you will want to put into your cluster. And this is just an example of some of the information that you would get in that report. It'll tell you all about the storage, it'll tell you about the networking, it'll tell you about the compute components. And if it doesn't pass, then you can still create the cluster, but you won't get support from Microsoft until you fix whatever the cluster validation wizard says needs to be fixed. So we ran this, and we can see that it did pass validation. So we'll minimize that, and we'll start to create the cluster here. So we start with the Before You Begin page. Now we need to enter the names of the servers that will be in the cluster. And so those are going to be HC2 and 5. Now, you can do that and then click Add, but you can also use a semicolon and do HC2 and 6. Press Enter. So we can create clusters up to 64 nodes, so you don't want to put them in one at a time, obviously. So you can use a semicolon there. So we assign the members of the cluster that are going to be in the cluster. Now we have to assign a name to the cluster. So we'll call this storage. All right, come on. Storage. Okay. Storage class 228. And then we have to assign an IP address that will be used by the cluster. So 228. Come on. The demo gods are not going to be kind, I see. Okay, 228. Let's go back here. Fix that. 228. Okay, so this is the IP address that will be assigned to the cluster. It validates it to make sure that nobody else is using that address. Now we want to make sure that we remove this check mark here because we don't want to add all available storage at this time. We actually want to create a storage pool after we create the cluster. So we will now create the cluster. You see it's forming the cluster now. Creating the resource types in the Active Directory. Ta-da, that worked. Very good sign. So now we'll give it a moment, and the console will then connect to the cluster. And there we go. So the next step is that we want to create a storage pool. And in this example, the storage cluster is going to take advantage of a new Windows 2012 feature called Storage Spaces. And what Storage Spaces allows you to do is use inexpensive SAS disks in a JBOD configuration, and you can add as many disks as you like, and you can pull those disks, and then you can, out of those pulls, you can carve out the equivalent of LUNs from those pulls, and we'll create that equivalent of a LUN as we go through this. So here in the failover cluster manager, we would expand the storage node, and then we go to pools. And we want to create a new storage pool. Come on. Come on, network, you can do it. Come on. It's, oh, please. Please, demo guys. Please connect. I guess that T1 to the United States went down, huh? Let me start over here. All right. Well, you know, you kind of have these nightmares, like things like this happen. Sometimes they come true. Let's see here. Make sure it's not a connectivity issue. ipconfig / DNS. A little network troubleshooting here. Okay, we have internet connectivity. Oh. Looks like my direct access died. You guys know what direct access is? It's a remarkable technology. But you know what's even more remarkable is SSTP. Let's see. Do you know SSTP, Secure Socket Tunneling Protocol? It's a new VPN protocol with Windows Server. Actually came with Windows Server 2008. And it uses SSL to tunnel the packets instead of like GRE for PPTP. So it tunnels through firewalls and stuff, and it's really nice. So let's see if good old SSTP saves us. Yep. We're not there yet. Let's see. Securing remote computer. Yesterday I ran into a problem where I couldn't connect to this server, it said I didn't have enough licenses, but I could connect to the other demo machines. And all right. Someone's having fun with me now. So I was getting this error that said I didn't have enough licenses to connect to the terminal server. And the fix was to delete a license key in the registry and then connect again, connect the RDP client and with elevated privileges, and then it started working. It made total sense, right? Okay. Oh my goodness. Okay, I'm going to try this one more time, and then we'll do a little slideshow, and maybe everything will come back together. Yes. Securing remote connection. Looks good, looks good, looks good, looks good. That's not a good sign. Okay. Let's look at a few slides, and maybe things will fix themselves. All right. So if and when we get connected, what I will have done here is connect and prepare the shared storage, install the roles and features that are required, because I have to install the file server role on the storage cluster, and then I have to configure the file server role to support a new feature that's called Scale Out File Server. And the Scale Out File Server is a new capability in Windows Server 2012 where we can host two specific workloads that require continuous connectivity. Those two workloads are hosting SQL databases on the file server and hosting VHDs on the file server. We take advantage of new capabilities in SMB3 to make that possible. Then I would go through the storage cluster setup. We saw the cluster validation results. We saw the cluster wizard. We didn't see me put the disk, create the virtual disk yet, but hopefully we will, and add that disk to the CSV, and then create the shared folders and the permissions that are required. There are also some network options and decisions we have to consider as well in our hosted cloud environment. One example is I require physical separation for all types of network traffic, sort of like that first version that we saw where we have one NIC for each of the infrastructure traffic modes, the tenant traffic management, live migration, storage, and cluster CSV, and it would look something like this, the first pattern I discussed with you earlier. Another possibility is someone has a requirement where they say, I require physical separation only for the infrastructure and the tenant traffic, so you only need one NIC or one team each for the infrastructure and the tenants, and so it would look something like this, the second design pattern that we looked at earlier. The third option would be I only have slots for a single NIC team. And that's very common with the condensed infrastructures that we're working with now, servers and blades, and so we would use something like this. Does anybody see this or is concerned about the security implications of this? Any security guys that get nervous about converging all this traffic through a single NIC? No, doesn't. Yes. It makes you nervous? Okay, so the question answer was that, it may not be so much of a technical issue, but there may be political, administrative, regulatory, risk management, compliance issues that you might run into, especially with auditors, I suppose, right? So if an auditor comes in and says, I would like to see the traffic paths for the different traffic profiles in your cloud infrastructure, not private cloud, but just any type of cloud infrastructure, and they see that we're coalescing all this different traffic, then maybe that could be problematic. In our compute and virtualization design, some things we might need to think about is they require compute and memory isolation for selected workloads. Isolation is a key security consideration when we talk about cloud, because cloud takes advantage of a shared pool of resources, and we have to make sure that we have, pretty distinct boundaries in physical separation, or at least strong logical separation between what's happening with those workloads, even to the extent where we may have some people that want processor affinity and NUMA set up so that their workloads never even share any memory or processors with any other specific workload, and we can do that with Server 2012. Others say that they may want to deploy scale units that mirror their fault domains. If you were at the principals talk yesterday, I talked about scale units as a way to add predictable capacity, and that fault domains represent a non-server failure that could take out a number of servers in a predictable fashion, so that we can think in advance about what kind of reserve capacity that we need to have in place so that we don't have any degradation of service. Because remember, as cloud providers, even within internal IT, we're service providers. We're going to go from corporate IT to become service providers for our organization. So if we want to do this, we could use failover clusters. And we think in the past, if you're a Windows person or a Hyper-V person, you probably have thought, well, I need live migration, right? And the boundary for live migration in the past was a failover cluster, so if you wanted to do live migration, you had to have a failover cluster. In Windows Server 2012, you can do live migration, you can use storage migration, and you don't have to have a failover cluster. So if your fabric management system is able to move these machines from server to server without a cluster, and you have stateless applications that don't need the high availability for the compute component that failover clustering provides, then you might not want to use failover clustering. But in this requirement, we want to scale units and fault domains to mirror each other, so we may use clusters. However, like I said, I have completely stateless applications. I want to keep the compute layer simple. We'll use standalone servers and fabric management without clustering. And then we could also take advantage of Hyper-V replica and live and storage migration to enable high availability and disaster recovery. Okay, let's see if the network is going to be happy with me now. Yeah, I'll let you watch. That looks like a good sign. Now we will try this. Okay, folks. Do you guys have wireless connectivity for your phones and tablets and anything? You do? No? You guys have a, can I tether to one of you guys? No. Let's Let's see what it says here. No internet access. Oh, wow. My phone died too. All right. They said, Tom, you really should do a recording of this thing. And I said, no, nobody wants to watch a recording. They want to see it live. And I had total confidence that the internet would be back in full swing because I had 2 days to fix it. Okay. Sometimes one's optimism gets ahead of reality. Wait a minute, we don't. Okay. So, if the demo were working, what I would have done is then the Hyper-V cluster. Then I would have set the BIOS to support SRIOV and install the Hyper-V role on the compute cluster. And then I would go through cluster validation like I did on the storage cluster. And then I would do some cluster tuning too by going into the Hyper-V configuration and setting the data location for the share that I'd create on the storage cluster. And then I would configure the virtual switch. The virtual switch on the compute cluster has to have the same name on each node and has to be configured in the same way, or else it won't work because the VMs have to be able to recognize the same name as they move from node to node in the compute cluster. And so these requirements here are the ones that would fit the design that I hopefully will be able to put together before the end of this, where we require cost-effective storage, file-based VHD storage, tenant physical separation for infrastructure and tenant traffic, high availability for infrastructure and tenant traffic, scale units that are the same size as the fault domains, and HA for stateful applications. So this is what I'm actually trying to build here. So that's the end of the slides just about. So, and I apologize to you profusely for putting you through this beating here. See, I really want to see this number shoot up here. Yeah, that's okay. This is a good sign. Internet access, internet access. Even more interesting is that another session after this one is depending on the fact that I get this all working, because he needs to then piggyback on the configuration I'm doing here. So. It did work fine for my hotel room, and I do have room for about maybe 8 people if you would like to join me. I'll pay for lunch. Look at this. We have 25 minutes left, and if I can get connected, I can complete the whole configuration in 20 minutes. All right. Well, I'm not going to put you through any more of this pain. I appreciate your forbearance in this matter. Let's see. Pointing out the different traffic profiles there. And then after I had the whole thing put together, I was going to show you some amazing things. I was going to show you I was going to create a virtual machine, and then I was going to pixie boot that virtual machine and start installing a Windows 8 client with Office on it. And we were going to see the pixie boot and the progression of that. And during the installation of the operating system, I was going to live migrate it to a second member of the cluster. And then as after it had moved to the second member of the cluster, then I was going to go to the storage cluster, and I was going to migrate the storage to another machine. And it would have been fantastic. You would have clapped, and you would have said, wow. Instead, we looked at this, so I apologize. So I'm not going to put you through any more of this. Do you have any questions or observations? Or I know what your complaints are. They're the same as mine. I did have the same session in Orlando, and everything worked. So if you want to check the channel 9 for WSV320, everything worked, and I think you'll enjoy it. I'm sorry it didn't work for me and you. But I will tell you a couple of things. There's a book that you can get for free right now if you don't already know about it. And you can get it in the pavilion in the Learning Center where the Windows Server IX booth is. So ask for the Windows Server IX booth, Information Experience, or where the MCTs are. And it's called Introducing Windows Server 2012. And it's really a great book for getting ramped up on an introduction of many of the cool new things in Windows Server 2012. It's a free book. Now, for a non-free book is a book that I'm writing with Yuri Diogenes, and it's a security book on Windows Server 2012 called Windows Server 2012 Security from Endpoint to Edge, the Firewall, the Network Edge, and Beyond the Cloud. And we expect to complete that and have it released by the first quarter of 2013. If you want more information about the configurations and the design patterns that I put together today, and you actually want to do it yourself, we have step-by-step from end-to-end guidance on how to build each of those 3 design patterns. This one here is the converged with file server, the thing that I was going to build today for you. And this one is converged without the dedicated storage nodes. That was the 3rd design pattern I described to you, where we converged all the traffic through the Hyper-V switch. So we already have those up. Those are confirmed and tested in our Enterprise Engineering Center, and we guarantee it'll work. If not, then please get my card before you leave if you want to test it, and you can write directly to me, and we'll try to figure out why it didn't work for you. Other sessions, the principles talk I did yesterday, you should check that out. Yigal Edery is doing the architecting talk. That's very good. The Hyper-V over SMB is great. SMB3, learn all you can about it. Storage services is great if you want to learn about the storage spaces capabilities. Oh, and this is for Orlando. I don't know if we're giving anything away, so I can't show you that. Thank you very much. You've been an excellent crowd for putting up with this, and make sure to check WSV320 on Channel 9, and you'll be able to see the whole thing work. So thank you very much. If you have questions, you can come up here. Otherwise, I thank you for your time and your patience.